So another use for an electromagnetic coil is in a motor starter, and I've got a combination motor starter here mounted on the wall. We call it a combination motor starter because it has up here at the top, it has a means to disconnect, so we can turn this on and off, which kills the power. And then if we go inside here, you'll see the disconnect switch at the top, and then also has fuse protection, and then it goes down to the motor starter here as well. And what the motor starter does is it gives us the ability, again, to use a low voltage. So in this case we're using 120 volts, and our line up here would be 240 volts. This would be a single phase motor starter, and we're going to have remote control ability. So we can have this coil get energized from, say, the front of the starter or from a remote location. We can also go into a situation where we have a hand mode, so we can have a start-stop that we can control, or we could go to totally automatic. We could run off a float switch or a pressure switch or something that automatically provides an input start to energize that coil and run that motor. So another example of a electromagnet, or a way to manipulate the electromagnetic field that we can produce when we energize a coil, is this item right here. This is just a small one, but these are all over our AC electrical system. This is the AC voltage transformer, and this was the brainchild of Nikola Tesla in the AC system. And what Tesla discovered is that when you use alternating current, it's very easy to transform that alternating current by using a transformer. And what a transformer is it's two windings. There's a primary winding over here on this side. There's a secondary winding over here on this side. And in between those windings, or in the middle of the windings, and wrapped all through the windings, is a laminated iron core. So usually always transformers are iron core magnetic type transformers, so they have this iron core as the center and the two windings. This transformer here is designed primarily for use in a doorbell, so the doorbell at your front home would use this transformer. And what you would do is, on this side, you'll see up here at the top it says line 120V, so this is our 120 volt side where we bring our line voltage in. And then on the other side you'll be able to see it says load, and it says 24 volt. And so these two screws are where we would get our 24 volts for our doorbell. That would be located at the front of our home. Now, the other part of the system for the doorbell is the mechanism that makes the chiming sound. And if you look really carefully, you look on the inside there behind, you'll see a winding of copper wire there. And also on this side, if you look back in behind there a little bit, you'll see some windings of copper. And a doorbell is just simply a winding of wire creating a magnetic field, and when that happens, this plunger comes down into the electromagnet when it's energized, okay? And then there's a spring mechanism that forces it back, and when it gets forced back, it hits the top of the doorbell mechanism, and you get the sound that someone is at the, in this case, the front door. Then over here on the other side we have a second one of those items, and the same principle, except this one is working in reverse. This one, when it is energized, it hits the bell and then it springs back. So this one, when it is energized, it makes the sound, and that's the different sound. That's your rear door. So you can have two separate buttons, one at the front, one at the back, each of them switching the 24 volts that energizes the solenoids the coils here on the unit that makes the sound.